So let's see about I'm Kevin, and I'm going to explain the topic about genetic algorithm. So this is my PPT. So let's move to the next slide. So basically, genetic algorithm means studying about genetics. So here's the content. This PPT includes introduction to genetic algorithms, key components and genetic algorithms, and application and benefits of genetic algorithms. So these are the basics. Then we'll go to the problem side. Okay. So yeah. So first slide is introduction to genetic algorithm. So this basically revolves around evolutionary computation, and this contains three types of approaches which I'll tell in this PPT. The first one is mimicking natural selection. So this is genetic algorithms or optimization techniques inspired by the principles of natural selection and genetics. Then population based approach. Genetic algorithm work with a population of potential solutions. So this works around like we have to find a solution to a problem. So this is the main reason for genetic algorithm. And the intelligent random searches. These algorithms intelligently exploit random searches. Like many search algorithms are there, like D like some search algorithms are there, so we can use that for searching the minimum path. Okay, so then these are the introduction to genetic algorithms. We'll move to the next slide. So this is how the genetic algorithms work. So how does a genetic algorithm work? Okay, this includes initialization, then we have to move to fitness assignment, then we have to move to selection, then reproduction, then termination. So these are the basic steps how the genetic algorithm works. So first, initialization stage, we have to initialize all the values, then we have to do a fitness assignment. We have to select which are the possible outcomes that will give the desired output, and we have to do reproduction, like splitting them into, and termination by cancelling the term which is not applicable for our problem. Then workflow includes initialization, selection, crossover, and mutation, which includes initialization, which is the algorithm starts with the initial population of potential solution. This is the question we will be getting. So yeah, then the selection is at each generation a pool of partners is chosen. So partners are chosen in this selection process. And the crossover and mutation, the selected parents contribute the genes through crossover. So by this crossover we can easily mutate the parents so that it gives the child nodes, and we can select the desired output from that. Okay, so we'll move on to the next slide. So advantages and limitations of this are first, a genetic algorithm offers several advantages, including the ability to work with problems having multiple local optima. So we can work with local optima in the problems. And limitations are, while powerful, genetic algorithms may face challenges in scalability. So if there are vast number of outcomes, then there comes the problem of taking which component should be taken for this problem. So these are the advantages and limitations of genetic algorithm. So we move on to the real world applications. So the real world applications includes engineering optimization. Genetic algorithms find extensive use in engineering for tasks such as structural optimization. Then financial modeling. They are applied in financial modeling for portfolio optimization. So in these two examples, we can see that genetic algorithms are used for structural, like in a graph-like manner, so that it can be easily found which is optimized technique to use to approach for a problem. Then the third one comes as data mining and machine learning. Genetic algorithms play a major role in feature selection, neural network training, and clustering tasks. So the third one is we are familiar about that. So data mining and machine learning, the main process is to feature selection, where genetic algorithm plays an important role in selecting a best feature for a problem. Then we'll move on to the neural network training. So the neural network training also requires some weights to calculate the desired answer. So this also plays a major problem. And then clustering task. These tasks are included for clustering the major part of the problem, and we can find the solution. So we move to the next slide. Key components of genetic algorithm. So chromosome representation. So how are these chromosomes represented? We know that chromosomes are represented as XY in biology, but in this problem we have chromosomes represented as binary terms like 0 1 0 1 like that. Okay, so binary encoding, chromosomes are often represented as binary strings, as we can see in the PPT, 0 1 0 0 1 0 like that. Okay, then custom encoding. In some cases, custom encoding such as real value permutation or tree based representation are used. So real values are used in cluster and custom encodings, and tree based representation are used. This comes under chromosome representation and how it can be represented. So we'll move on to the next slide. So next slide tells us about the selection methods. So these selection methods are roulette wheel selection. This mechanism assigns a probability of selection of each individual based on its fitness. So based on fitness, this roulette wheel selection is used. And tournament selection. Individuals are randomly chosen from. So there's a random population, and individuals are chosen from the population. So this is called tournament selection, and we'll move on to the next slide. Crossover and mutation. This plays a major part in every problem genetic algorithm. So crossover operators are single point, multi-point, uniform crossover or common techniques. And mutation operators are mutation introduces random changes to the offspring. So yeah, second one tells us about the mutation, which introduces many changes from the starting point to the ending point. If you see, the mutation operators play a major role in changing the offsprings. Okay, you know what to make. Convergence and termination. Yeah. So convergence criteria requires genetic algorithms which terminate when a specific conversion criterion is met. So there's threshold value. If the threshold value is met, this convergence criteria terminates the process. Then termination conditions. There are a few termination conditions which will be seeing later. So other termination include reaching a predefined computation budget. So this also requires some cost kind of things. So we'll move on to the next one. Applications and benefits of genetic algorithms. So the main application are obviously structural design. Genetic algorithm is the design of structures. So designs are optimized. Then aerodynamic shape optimization. They aid in shaping aircraft wings, vehicle bodies, and aerodynamic components. So in aerodynamics, genetic algorithm plays a major part. As we see, we can design vehicle bodies and other aerodynamic components in these. Okay. Then evolutionary robotics and control. Robotics application requires genetic contribution to the evolution of robotic behaviors. Yeah, since we human have genetics, the robot also to behave like human, they also have genetics. So we use the computational genetic algorithms. Then control system design. They optimize the design of control systems such as PID controllers, etc. Then we go to financial modeling and portfolio optimization. This includes algorithmic trading strategies. Genetic algorithms develop trading strategies by evolving trading rules. Portfolio management includes they optimize investment portfolios by selecting the optimal mix of assets. So this PPT tells us about the data mining and machine learning part. This also plays a major role. So ethical considerations. Fuzzy optimization models raise ethical considerations related to transparency, accountability, and fairness in decision making process, requiring careful evaluation and governance. Next, the public awareness. Increasing the public awareness of fuzzy optimization benefits and challenges is crucial for fostering informed discussions and decision making related to the implementation of fuzzy system. Then policy implications. Fuzzy optimization's societal impact necessitates the development of policies and regulations to ensure the responsible and ethical use of fuzzy systems in decision support system. So this includes this. Then we move on to the problem. So this problem mainly focuses on genetic algorithm, and it says that maximize the function f of x is equal to x square. Okay, so we'll move to the next slide. So just consider the function of maximizing the function f of x into x square, where x is permitted to vary between 0 to 31. So we have to take the x as 0 to 31, and this is our own value. Okay, so okay, the maximum value is equivalent to 31. Now we will apply the genetic algorithm step by step, and then we will try to get the maximum value for this particular function. The first step in genetic algorithm is selecting an encoding technique. To represent the solutions, we know that the minimum value for x is equal to 0 and the maximum value is 31. The solution will lie between 0 to 31, and here we need how to represent the particular solution. Somehow, for the reason, we have to use some encoding technique in this case. So we take a 5-bit integer numbers between 0, 0, 0, 0 and 31, 1 on 1 can be obtained, and the function is f of x, which is to be maximized. So then we have to select the initial population, so the sum of the solutions, and then we have to need to apply the remaining steps for the particular genetic algorithms. So to start with, select initial population are random. Here initial population of size is 4 is chosen, but any number of populations can be selected based on requirement and application. The table we will be drawing next will be shows the population which is randomly selected. So this is the table, and this shows the string number. First we have to name a string number, initial population, x value, fitness, f of x is equal to x square, probability, and probability percentage, expected count and actual count. So first we have to write the string number 1 2 3 4, the sum, average and maximum. Then we have to write the initial population which we chosen randomly. So x value of the initial population is written 12, 25, 5, 19, and fitness we have to check the fitness where f of x and x square, okay, f of x and x square is equal to, so x value is 144, 25 square is 625, 5 square is 25. So probability is we have to use a formula and find the probability. So these are the probability, and percentages we have to divide into 100, so 12.57, and we have to find the sum. So the expected count we have to use the formula which we seen before, and we have to find the expected count. So yeah, then we have to find the actual count, which is equal to 1 2 0 1. So for the next iteration we have to find the crossover point in mating pool. So the actual count is 1, and the second has 2, and the third has 0, and the fourth has 1. So we have to take 1 or 2, 3 we should not take 3 because there's 0. Okay, then we have to take 4, which is 1. Okay, then we will move to the next table. Draw next table which has string number, mating pool, crossover point, offspring after crossover, x value, and the same f of x fitness value. Okay, so yeah, string number is 1 2 3 4. As we seen before, you have to take the string number in the before problem, and we have to select the crossover points which is randomly selected by ourselves. Then we have to offspring after the crossover is we have to split the values, and we have to find the crossover. So 0 1 1 0 1 1 1 0 0 0 1 1 0 1 1 1 0 0 1. Okay, so the by converting the binary into the x value, we get 13 24 27 17. So by using f of x value, we find the fitness x square. So 13 square is 169, 24 square is 579, 27 is 729, and 17 is 289. So sum, then average is divided by 4. So maximum between these are 729, and the previous, the actual count is 1, and the maximum is 625. Okay, 625. So we move to we have to find the third iteration and of the third table. This includes string number of spring after crossover. So after the crossover, this we have to write there. Then the mutation chromosome for flipping, I will explain this. Then offspring after mutation, x value, and fitness of f of x and x square. Okay, so write the string number 1 2 3 4, sum, average, maximum, just like the before table. Then move to the offspring after crossover. We have to write the same, these 4 values in here, and we have to find the mutation chromosome. This is like See the first values of the offspring after after crossover table 0 1 1 1. So we have to flip the bit here, so 1 0 0 0. This is the part we will be doing here. So we have to flip the 0 to 1 and 1 to 0, 1 to 0 and 1 to 0. Okay, so offspring after mutation includes like we have to find the mutation between these both two. This includes 1 1 1 0 1, then 1 1 0 0 0, then 1 1 0 1 1, into we have to multiply, then 1 0 1 0 0. Okay, so by converting the binary values into the bit values, we get 29, 24, 27 and 20. So by using the fitness value f of x, we find the 841 29 square, and 24 square is 576, 27 square is 729, and 20 square is 400. So we have to add all these and we get 2546, and by taking the average we get 636.5. So the maximum value between these number is 841. So by comparing the previous values like 625, 729 and 841, we find like 841 is the highest value. We find 841 as the highest value, and then we need to apply the mutation. Once you apply the mutation, you will get the next generation, and we have to go generation after generation, and we to get the fitness value and increase compared to the previous one. So same thing have to be repeated again and again, unless you will get the maximum value for a particular function like 625, 700 and 841. So we get the maximum value. So since the maximum value gets stopped, we have to stop the iteration. So this is the function, and we get the maximum value, or we can maximize the value as particular, we can do it afterwards. So this is the concept of genetic algorithm, and if I clear this video will I mean my explanation will reach all of you, and hope you understand. And this is my DA2 in optimization techniques. Thank you.